Now that we have our idea of what it means to be mutually exclusive in mind, we can define the addition rule. The addition rule is for dealing with cases of either or. You get this or you get that. And if we have disjoint events A and B, then we say the probability of getting A or B is the probability of A plus the probability of B. Where a very simple example of this would be something like a coin flip.
Call it.
If you flip a coin,
And it's either heads or tails. And you have to decide, call it.
technically you can land on its side. We don't worry too much about that case because it's a bit too unusual to consider. Point is, you have one or the other. You can't get both.
Heads, eh? Well done.
Unless you're cheating somehow, which generally we assume we're not for the sake of fairness and reasonability and probability and computation. So we just get PA plus PB. Very straightforward, and you can chain this further on for more and more events. Then, for not mutually exclusive A and B, that is for not disjoint A and B, we have that the probability of A plus the probability of B minus the probability of PA and B is equal to the probability of PA or B, where we can understand this thinking back to our ideas from chapter 2 in terms of Venn diagrams. That when we're trying to count the probability of A or B, we get that bubble for A, we get the bubble for B, but then we also get the overlap in the middle there in each case, so we have to kick that out with that minus PA and B. Where this gets more complicated as we have more and more cases, it gets into a thing called inclusion and exclusion that we're not going to worry about too much in this class, but that is worth mentioning. So, for something like this, if I roll a die, we can understand here that if I look at something like the probability of getting a odd number or a 3, something like P of 3 or odd, that in this case, we're going to talk about the probability of getting a 3, there's only one way to get a 3, along with the probability of getting an odd number, but we have to remove the probability of getting, well, 3, I'll just use an abbreviation there, and odd, because 3 is itself an odd number. That is, when we count the probability of 3, which is weird to say because that's just 1 out of 6, then we count the probability of getting an odd number. That would be 3 out of 6. We've counted 3 here, we've counted 3 there, so we need to remove that double counted case, and what we will get here just ends up being, down to some simplification, 3 out of 6, or as most would prefer to say, 1/2. The reason for this being that when we're counting both of those things, all of the things in odd include all the things in the 3, so again, we can use our ideas from before, talking about things like subsets and how those interact with unions to get the same sort of idea, because the addition rule is essentially the same as when we were talking about unions way back in chapter 2. So, let's get some more of an idea of how this is going with a couple more examples.